Hello everyone, whoever is watching this video. I chose to do my individual design project on within grade 8 mathematics using Sphero. So I attempted to do this on a Google Hangout on air, but it appears the link isn't working properly. So I'm going to try to redo this and resubmit this way, and hopefully it works this way. So let's try it out and see how it goes. So I'm going to walk you through my project. So here's the introductory slide as we would have it. Now the lesson goal for what I'm trying to do is have students code a Sphero robot to make geometric shapes with proper angle relationships, which supports goal number 4 of the Sustainable Development Model, Inclusive Education for All and Lifelong Learning. So in order to achieve this end, we will video our findings, or I guess I would, or any teacher who elects to use this lesson, and we will connect with other schools via either Google Hangouts or YouTube. So you have different choices there just in case one of them doesn't work or a certain teacher isn't as familiar with one of those resources, they can elect to use the other. The lesson. So in terms of lesson preparation, we are talking about a grade 8 mathematics class in geometry and spatial sense. You are required to have 8 Spheros, washable paint, large white paper, water, and 8 iPads. Now I am fortunate enough to have a lot of these as I've purchased them over the years, and I've had assistance in getting others. Others would have to borrow them, but the nice thing is if you work within Thames Valley or a lot of the other school boards, they're making a big push within maker spaces, so they are getting some of these items readily available within their school, or they could borrow them from their school board. Overview. So here's an overview of the lesson. It is supposed to be cross-curricular in nature, so it is grade 8 again, and subjects is primary focus is math, and the secondary is art. The curriculum expectations is to solve angle relationship problems involving triangles, so finding interior angles or complementary angles, intersecting lines and parallel lines. Determined through investigation using a variety of tools, which we are definitely doing, and this is where the heavy technology component will come in. But also not to neglect the art expectation that we are achieving. So we're using a variety of materials, tools, techniques, and technologies to determine solutions to increasingly complex design challenges. Well, I would say making mathematical shapes in the way that we are going to do would definitely classify as a design challenge. So moving along, the overview continued. The UN Development Goal number 4, as I mentioned earlier, ensure inclusive and quality education for all and promote lifelong learning. What I found really interesting about this is by 2030 that we want to ensure that they want to ensure that all boys and girls have access to quality early childhood development. And that they also are ready for primary education. So by using some of these technological tools, they are actually embracing skill set acquisition, which will help them in the future in terms of coding and different things that we're going to go over in this lesson. Some of the tools that are required, again, are the Sphero robots, the iPads with either the Tickle app, Lightning Lab, or Scratch, which is a block-based program, large paper, and washable paint. So the culminating product is a work of art that illustrates concepts from within geometry and spatial sense. So students will have created a shape which they programmed, and then the Sphero will actually draw the shape on paper via the paint. You're going to see that in a little bit as I've actually conducted this project, and you'll see my findings. Finally, this project will be shared online to help extend learning beyond the classroom. And that is one of my big mantras in terms of in our classroom is take the learning beyond the doors so that others can benefit, even those who aren't in your room. So moving along the lesson, so we have our minds on. So the minds on, this is more meant as a kind of a diagnostic lesson or an early entry for the unit. But we would show students Sphero, if no prior knowledge, which is this guy right here, this robotic ball that uses Bluetooth technology. You don't even need Wi-Fi. Tell them we will be programming this robot to make a piece of art today using paint. Now tell me when you mention that, what kids aren't going to be excited to do that. So we would then model Scratch program or the Tickle application and show them how to make a square using student-friendly block-based programming. So in the upper right-hand corner, we have Scratch and how to actually make a triangle. And the code that I actually use to program here is below, and we would have them do a lot of this as part of our lesson. So we'd model how to use it in the blocks. Now my students are pretty familiar with both these platforms, but for any teacher who wanted to get started and do this, it is easy, they can do it, and it does teach and embrace a lot of computational thinking skills. So then they would replicate the code on their own and ensure they can make a square. And then you would have them change the dimensions to make a triangle. So once they have the square down and they talk about all the different angles and they're making multiple right angles, then you would have them change the dimensions so can they make it bigger? Can they make it smaller? How do they do that? And then you can put out kind of a bigger question and an inquiry question. How would we change the shape of this? And you get a lot of students who have that aha moment when we do this, and so I love it. So the action in the lesson is students complete the code and test that it is correct. When complete, they have shown the teacher and they get paper and paint and they actually get to begin the final product. So this is one of my students here working with a Sphero on the ground. Doing activities similar but not quite that. The Hacked Education shirt is for a nonprofit venture, something that I started here in London. The Google Hangouts on air is because that's what we'll be doing to connect and achieve our developmental goal. And I put in an extension here for any students who complete this task rather quickly or are more familiar with coding. Students must make 3 shapes which have one of intersecting lines, complementary angles, or alternate angles. So this will really push those gifted learners or anybody who's really fast and complete. And I really like to motivate them to do this because I find then that their enhancement in the task and engagement really goes up. Students, once they've completed their task, the teacher will videotape and post these to the class YouTube page. So I want to actually show you what I did for this activity, and you can take a look.
Okay, so for our activity today, what the students would do is they would have one robotic ball, which is named Sphero, which is right here. So we'll leave him there. They would also have their iPads as described in my lesson plan, which is right here, along with the code sequence that they need in order to make a triangle. So what I'm going to do is I'm going to try to add some green paint, which I know seems a little crazy, to Sphero. The good thing is that you can actually wipe this off after, and it is just washable paint. It's nothing too crazy. So you do have to actually kind of play with this, and that's one of the good challenges of the lesson, is you can actually let the students try and see how it goes. And if they make an error, they can see how can they perfect this and change the angle or velocity, anything they need to do in order to make it a more successful experience. So what I'm going to do is I'm going to try to see if I'm lined up correctly here. Looks like I am. So what I'm going to do is I'm going to try to run the program and we'll see how messy this gets. And as you can see, we've made a triangle a little off the paper, but that's okay because it is washable paint, and I hope you guys enjoy.
So that was the video, and that's actually the activity and how it would go. Now it makes it look simple there, but for the kids to actually get to that point, that is what where the learning occurs, and it doesn't stop there because they connect with others. So in terms of a consolidation, I have created a form which the students would have to complete afterwards as their exit ticket. So you would click on your exit ticket. That would bring you back into a exit ticket form. What was your favorite part of the activity today? Using Sphero, coding using block-based design, connecting with other students via Google Hangouts, collaborating with other classmates. What was the most difficult part about today's activity, and what did you learn from the other students outside of the class? So that's where it ties everything in together and really brings it back to what we're trying to do here in terms of our sustainable development goal. Beyond that, the conclusion is that students will have gained increased comprehension when in terms to angle relationship problems through this activity. This activity increases computational thinking as well as higher order thinking skills. It's cross-curricular in nature, and they get to utilize several educational technologies in order to achieve the desired learning goal. Finally, we extend learning to other cultures and communities via YouTube and Google Hangouts to complete our UN objective. So thank you very much. I hope you enjoyed.